Hi everyone, in today's lesson we're going to review all components of the unit circle. So let's first discuss the radian and degree conversions. So if I want to go from radian to degree, I want to multiply by 180 over pi. And if I want to go from degree to radian, I multiply by pi over 180. Those are the rules. We're going to use those in just a second for the unit circle. So let's draw ourselves a basic unit circle. All right, so a unit circle is a circle that is centered at the origin. So we can draw one here. Do your best to draw a circle. And if we're centered at the origin, then the circle will cross the x and y axis at 1 unit away. So here to the right is the point 1, 0. Up here on top is 0, 1. Then we have -1, 0, and 0, -1. Those are the 4 main points of the unit circle. Now, we should remember that the first degree measurement here is 0. Then we go up to 90, and then down to 180, and 270, and to complete the circle, we have 360 degrees. Now, if you use the radian conversion above that I just discussed, you can convert each of these 4 quadrantal angles to radians. So 0 is still 0 radians, 360 is 2 pi, 90 will be pi over 2, 180 is pi, and 270 is 3 pi over 2. So those are the main radian conversions. You'll learn that in calculus, we use a lot more radians than we use degrees. So let's try to get comfortable using those. All right, what else do we know about the unit circle? Well, the x value is equivalent to the cosine of an angle. The y value is sine of theta. Y divided by x, or sine divided by cosine, is your tangent of theta. And then we can use our reciprocal pairs, right? We know that 1 over x is the reciprocal of cosine, which is secant. We know that 1 over y is the reciprocal of sine, which is cosecant. And we know that x over y is the reciprocal of y over x, or sine over cosine, which is tangent. So the reciprocal of tangent is cotangent. So it's cos over sine, and then it would become cotangent. So I could ask you to use this unit circle to find any of the values at any of the given times. So if I wanted to find, let's say 90 degrees, right? Let's just say I wanted to find sine of 90 degrees. Well, it'll help if I highlight it here. Let's just say I make sine blue. So sine of 90, or even all of them, sine is my y value. Let's say I make yellow my x value. So x is my cosine, which would be here in all spots. So if I care about, let's say 90 degrees and I want sine of 90, it's simply 1 because sine is the y value. If I want cosine of 90, I want the x value, which is 0. So same thing would apply if I wanted secant of 90. Secant of 90 is 1 over the x value. Well, the x value is 0. So 1 over 0 would actually be undefined. So we could use that unit circle to find any one of these 6 trig functions at any given time. We'll discuss that more in class, but here are the basic definitions for now. Alrighty, let's take a look at the next part, which is the exact value chart. Now, some teachers use, the unit circle, but I use the exact value chart to find the exact values of 30, 45, and 60. So we're going to set up our chart like that across the top, and down on the columns here, we're going to do sine of theta, cos of theta, and then tan of theta. And this is where theta would go, right? So to fill in the chart, I'm going to show you a little rhyming trick, I guess, if you would. So it goes 1, 2, 3, 3, 2, 1, all over 2. So 1, 2, 3, 3, 2, 1, all over 2. And then everything on top gets a radical, except for 1, because the square root of 1 is just 1. And the last row of tangent has everything to do with 3s, a little harder to remember, but it's rad 3 over 3, 1, and then rad 3. Remember that tangent is sine divided by cosine, so this middle section makes sense, right? Rad 2 over 2 divided by rad 2 over 2 is 1. So that's just a way to explain where everything comes from. So if you divided 1/2 by rad 3 over 2, you'd get rad 3 over 3. And if you divided these two, you would get that last one. So at calculus, it's kind of expected that these things here in this first page are known and memorized. So in order to be successful with the rest of the unit, you're going to need to know these things. All right, we have one last thing that we need to go over. So the other things that you'll need to know is unwinding the unit circle. So the unit circle can help us get our basic sine and cosine graph. So I took the liberty of giving you a unit circle already, and I'd like to graph a sine of x function first. Now on this x-axis here, we need to put the radian measures of the degrees. So the degrees actually go on the x-axis, and the exact values go on the y-axis. So we had talked about radian before, so we go 0, pi over 2 for 90, pi for 180, 3 pi over 2 for 180, and 2 pi for 360. So here we're going to do 1, 2, 3, 4 tick marks, and we're going to start at 90 degrees. Obviously 0 is at the origin there. So pi over 2, pi, 3 pi over 2, and then 2 pi. So if we want to graph our sine curve, remember that sine we said was the y value, we're going to graph just these y values starting with 0 degrees. So when we're at 0 degrees, here the y value is 0, so my first point is here. Then when we're at 90 degrees, my y value is 1, so I need to put a tick mark here somewhere. We'll call that 1. And we're going to put a dot here. Then at pi, or at 180 degrees, sine, or the y value, is at 0. Then at 3 pi over 2, the y value is at -1. So I need to put a tick mark down here at -1. And then at 2 pi, we're at y value is 0. And if we make our connection, curvy of course, that is my sine curve. So this is obviously cyclical. It could go on forever in both directions. So that, though, is your first main graph, which is sine, which always starts at the midline, which is here. All right, I'd actually like you guys to try to graph cosine and then pause the video until you've done so and then hit resume for the answer. All right, here we go. This is what I got. So just to recap, cosine is the x value. So I'm starting at 0, which is here 0 degrees. The x value is cosine, so 1, then 0 at pi over 2, then -1 at pi, 0 at 3 pi over 2, and then back up again at 1. So that's it for my basic sine and cosine graph. Sine, if you take a look, always starts at the midline, and cosine starts up here at my maximum. And last but not least are the other two graphs. We've got negative sine of x and negative cos of x. So negative sine of x actually is a reflection of positive sine of x, but over the x-axis. So if this is your sine of x graph, right, this one is your sine, I need you to reflect this over the x-axis. So this piece would go here, this piece would go here. So your graph of negative sine of x still starts at the midline, but this time goes down, up, down. And those are your 4 same tick marks. So this would be pi over 2, pi, 3 pi over 2, and 2 pi. Same concept. And if you want to graph negative cos x, same thing. You'll start with your graph of cos, which we said looked like this. So you're going to graph the reflection. So if you reflect each of the pieces over the x-axis, it will look something like that. So my negative cosine graph starts down here at the minimum and goes up, down, up. Again, same of those 4 points. Here's 1, 2, 3, and 4. So this one is your pi over 2, your pi, your 3 pi over 2, and your 2 pi. So again, something that you need to know for calculus is what these 4 graphs look like. All right. I know that was a lot of review, so don't worry. We'll review how to apply all of this stuff to actual problems tomorrow in class. All right. Have a good night.